Alright, we're going to do section 5.3 of the homework, and it says 42. What is this graph if you compare it to that one? And so e to the 3x goes through 1/3 and 1 and 3. Well, that looks like if I were to move this equation over 1, then reflect it over the x-axis, I would get, or over the y-axis, I would get this. So to move it left 1, it would be x plus 1, but then I have to reflect it. Now I could have reflected it already to start with, so I need a negative on the x to reflect it. Now this would happen first when this, because remember, it looks like the negative would happen first for reflection and then add 1, but it always works opposite. So this would happen first. That would move it minus 1. So I'd take the original curve to here and then reflect it, which would end up there. So that one, I think it was G that had that equation in it. It actually had 1 minus x. 43. Says, what's the domain of this? Well, you can use any number for x. So that's all reals. It says, what's the range? Well, 2 to the x will look like 2 to the 0, 2 to the 1 is 2, 2 to the is a half, if it's to the minus 1. And if I go plus 1, that moves it up 1. So the lowest it gets is right down to 1, but not including 1. So the range is all x such that x is greater than 1. Or we could say from 1 to infinity. And it has a horizontal asymptote of 1 instead of 0. Y equal 1. 48. It says, what's the domain and range and horizontal asymptote of this? Well, this is related to the 3 to the x. Parent function would be f of x equals 3 to the x, and that looks like goes through 1 and then 2, 3 at 1. Goes through 1 there and at a third. Looks like this. So the 1/3 just changes this to a negative, and that would make that 1/3. That would flip it this way. And then the 4 stretches it vertically, so it'd be, instead of going through 1, it'd be going through 4, so it would be more like this. Steeper. So what is the domain? Well, we can still use from negative infinity to infinity, so it's all reals. The range is from 0 to infinity, not including 0, because the horizontal asymptote would still be y equals 0. 54. What's going on here? Well, this is the parent function is y equal 2 to the x. But this is a lot of changes on it. Let's get this kind of straightened out here. So we actually have y equals 2, and it looks like negative 1/3 times x, and then it has a minus 1 in front of this, and then it has plus 1. This is a plus 1 on the outside. This is times a minus 1 on the outside of the parent function, and negative 1/3 on the x. So y equals 2 to the x goes through 1 and 1, 2, and a half and a quarter, and 2 is 4. And now I have to, let's see, let's start at the x. Negative on the x would flip it this way. 1/3 would make it 3 times as wide, so this was over 1. Now it's back 1, so it's now back 3. And this one that was back out 2 would be back 2, and then times 3 times as far, so it's back at 6. So it's going like this, stretched out, flipped over, and 3 times as wide, and then the negative flips it over. So it would go down here and flip it over, stretched way out, and then plus 1 moves it up 1, so it go through here, and now it has a horizontal asymptote of plus 1. So the domain, we can still go from negative infinity to infinity, all reals. The range, it's moved up to, the asymptote is at y equal 1, so the range is from 1 down, so we go from negative infinity up to 1. Quite a few changes in there, all the transformations, little tricky to do. Now 55. Okay, so we're supposed to use this to graph this. Well, all they did was change the sign on the x. So y equals e to the x, e to the 0 is 1, e to the 1 is e, which is about 2.7, and 1 over e, if I put in negative 1, is about 1/3, and so this thing looks something like this. And if I put the negative on the exponent, it just flips it over the y-axis, so it's going to look like that. Where this is 1 over e, and this is 2.7 at negative 1. A little steeper there. That's all I needed to do for 55. 63. It says solve this. Well, they have the same basis, so x must equal 3. Way too simple. 63. They both could be base 3. So this is 3 to the x squared minus 7 equals 3 to the third to the 2x, which is the same as 3 to the 6x. So I'm down to this quadratic. X squared minus 7 has to be 6x since the bases are the same. So I'll subtract 6x and I get x squared minus 6x minus 7 equals 0. That factors to minus 7 and plus 1. That would make a negative 7 over here, x squared over here, and the outside's plus 1x, inside's minus 7x, so that's minus 6x. So x would have to be 7 or negative 1, and I believe both of those work. You could check that. These have the same bases in 80, so 3x must equal 2 minus x. Add x to both sides. Divide by 4 and reduce. X equals 1/2. 83. This, they don't have the same basis, so I could solve for x by changing it to a common base. But really, to get 4 to the x to be 4 to the minus 2x, I got to raise this size to minus 2. And then I multiply the powers and I get this. So it must be 7 to the minus 2. And 7 to the minus 2, that's 7 squared of 49, but to the minus puts it in the denominator. So it becomes 1 over 49. Okay, and then this one. It says if 2 to the, find out what 2 to the x is if 2 to the negative 3 is this. So to get rid of the negative 3, I can raise both sides to the negative 1/3. And that would cancel this. So I'd get 2 to the x, which is what they want me to solve for, would equal 1 over 1,000 to the negative 1/3. But 1,000 is 1 over 10 to the third. But 1 over 10 to the third is 10 to the negative 3. And negative 1/3 times negative 3 is 1. So 2 to the x must have been 10. And that's 5.3.